Alright, let's take a look at some examples where we're asked to find an nth term of a sequence. Okay, so let's take a look first of all at this sequence. Now this looks a little different because we're starting with a negative number, but that's okay. We can look at the common difference, and you can see we're just adding 4 each time. So negative 12 plus 4 is negative 8. Negative 8 plus 4 is negative 4. So we have an arithmetic sequence. So the 100th term of this sequence will just be the first term, which is negative 12, plus a multiple of the common difference. And the multiple that we want to add is n minus 1, so it's going to be 100 minus 1 times 4. Okay? So we'll just get negative 12 plus 400 minus 4. Okay, and all I'm doing is using the distributive property. And I'm taking 4 times 100 and 4 times negative 1. So I think 400 minus 4 is easier to calculate than 99 times 4. So if I do that, then I should get 384, right? 396 minus 12. Okay, so 384. So that's our answer. Okay? Pretty slick, huh? Alright, let's do one more example. These aren't too bad. Here we have a little different example here because instead of numbers that are increasing, we have numbers that are decreasing. But that's okay. It can still be arithmetic. It looks like we're going down by 6 each time. So we're subtracting 6 to get the consecutive number. So instead of a positive common difference like we've had in the previous examples, we've got a negative common difference here. Okay? So, but that's okay. In this case, D is equal to negative 6. And so we'll just use that negative number. So we've kind of set a reference that, you know, if the numbers are increasing, our D is positive. If our numbers are decreasing, then our D is negative. Okay? So A100, we're asked to find the 100th term. It's going to be the first term, 35, plus a multiple of the common difference. So that's n minus 1, which is 100 minus 1, times a negative 6. Okay? And, again, if I use the distributive property here, here I get 35 minus 600, because negative 6 times 100 is minus 600, and negative 1 times negative 6 gives you a positive 6. So if you add that up, you should get a negative 559. Okay? Now it's always a good idea to check your answer and make sure it makes sense. So if you were to get a positive 559, or really any positive number, that it just wouldn't make sense, because here you're decreasing by 6 each time. You're eventually going to get to 0 pretty soon. In less than 100 moves, you're going to get to 0, and then you're going to have to go negative. So it makes sense that this is a negative number. So it's always a good idea to check your number and make sure it makes sense. Okay. Now another way is to look at the general case and just come up with a formula for the general case. And then once you have the formula for the general case, then you can just plug in n and get any number in the sequence. So in this case, we have 35 plus n minus 1 times a negative 6. All right? And again, we can use distributive property. Multiply through by the negative 6, and we'll get 35 minus 6n, right? Because negative 6 times the n give you minus 6n, plus 6. All right. So the general formula for an is negative 6 times n plus 41. Okay? And then you can plug any number into this formula and get that term in the sequence. So if you wanted to plug in 65, you could take 65 times negative 6 and add 41 to it, and you'd get whatever that term was. So it's kind of handy to have the general formula, you know, if you're asked to find more than one term in the sequence. Okay, so that's kind of a good thing to know too. So you could plug in 100 to this, so A100. By just plugging right in there, you get minus 600 plus 41, which gives you the same thing. So there you go. You ought to have enough information between this lesson and the lesson on Gaussian addition to be able to do the worksheets on arithmetic series and sequences. So go ahead and do the worksheets and practice what you've learned.